Welcome. Today we are mastering simultaneous equations for the IGCSE extended curriculum. We will cover three main objectives. First, we will solve two linear equations using substitution and elimination. Second, we will look at how to solve them graphically. And finally, we will solve one linear and one quadratic equation. By the end of this lesson, you will be able to tackle any simultaneous equation problem from your exams with confidence. Let's look at our roadmap. We have algebraic methods, the graphical approach, and linear quadratic systems. Let's dive in. Our first objective is solving two linear equations using the elimination method. This is often the quickest way when equations are arranged in the same format. Consider these two equations from an IGCSE paper. 3x plus 2y equals 17 and 5x minus 2y equals 7. Notice something special about these two equations. The coefficients of y are opposites, plus 2 and minus 2. If we add these two equations together, the y terms will cancel out completely. Adding them up, 3x plus 5x gives 8x, 2y plus negative 2y is 0, and 17 plus 7 is 24. Now we have a simple equation with one variable. Dividing both sides by 8, we find that x equals 3. But we aren't finished yet. A simultaneous solution needs a value for both x and y. To find y, we substitute x equals 3 back into either of our original equations. Let's use the first one. 3 times 3 is 9, so we have 9 plus 2y equals 17. Subtracting 9 from both sides, 2y equals 8. Dividing by 2, we find that y equals 4. So the solution is x equals 3 and y equals 4. You can always check your work by plugging both values into the second equation to see if it holds true. 5 times 3 is 15, minus 2 times 4 is 8, and 15 minus 8 is indeed 7. Our solution is correct. Now, let's look at the substitution method. This is particularly useful when one equation is already solved for one of the variables, or is easy to rearrange. In this exam-style example, the first equation tells us exactly what y is in terms of x. We can take this expression, 2x minus 3, and substitute it directly into the second equation, where the y used to be. Substituting gives us 3x plus 4 times the quantity. 2x minus 3 equals 32. Now we expand the brackets. Combining the like terms, 3x and 8x, gives us 11x. Next, we add 12 to both sides of the equation. Dividing by 11, we find that x equals 4. To find y, we go back to our very first equation, which was already set up for y. This becomes y equals 8, 3, which is 5. So our coordinates for the solution are 4, 5. Substitution is a reliable method that avoids the need to multiply entire equations to match coefficients. Sometimes, the exam might ask you to solve these equations graphically. It is important to remember that the solution to a pair of simultaneous equations is simply the point where their two lines cross. Let's look at these two linear equations. On a graph, the first line, y equals x plus 2, has a y-intercept at 2 and a gradient of 1. The second line, y equals minus 2x plus 8, starts at 8 on the y-axis and goes down 2 units for every 1 unit it moves right. Look at where they intersect. They meet exactly at the point where x is 2 and y is 4. This means that the solution to the simultaneous equations is x equals 2 and y equals 4. Let's check our work. For the first equation, 4 equals 2 plus 2, which is true. For the second, 4 equals minus 2 times 2 plus 8, which is also true. If you are asked to solve graphically, accuracy is key. Ensure your lines are straight and your points are plotted precisely. The intersection point is the only pair of values that satisfies both equations at the same time. Now, we move on to a more challenging topic often found toward the end of the IGCSE extended paper, solving one linear and one quadratic equation simultaneously. We have equation 1, y equals x plus 1, and equation 2, y equals x squared minus x minus 2. Unlike two lines, which usually cross once, a line and a curve can cross at two different points. This means we should expect two pairs of solutions. For this type of problem, substitution is almost always the best approach. Since both equations are equal to y, we can set them equal to each other. So, we write x plus 1 equals x squared minus x minus 2. To solve a quadratic, we need to move everything to one side so the equation equals 0. We will subtract x and subtract 1 from both sides. Now we have a standard quadratic equation. We can solve this by factoring. We're looking for two numbers that multiply to -3 and add to -2. This gives us the factors x3 times x plus 1. This gives us two possible values for x equals 3 or x equals -1. To find the corresponding y values, we substitute each x back into the linear equation, as it is the simplest one. In your exam, make sure to clearly list both pairs of coordinates, 3, 4, and -1, 0. These represent the 2 points where the line cuts through the parabola. Let's wrap up with a summary of what we have covered to ensure you are exam ready. Elimination is best for linear equations with matching coefficients. Substitution is ideal when one variable is already isolated, especially for linear quadratic pairs, and the graphical solution is simply the intersection point of the two graphs. When you approach a question, first identify the types of equations you have. If you see an x squared or y squared, you are dealing with a quadratic and should default to substitution. If they are both linear, choose the method that looks the least messy for the numbers provided. Always check your answers by substituting them back into the original equations. Remember, the goal is to find the values that make both equations true at the same time. With practice on past paper questions, these steps will become second nature. We have solved linear equations via substitution and elimination, interpreted solutions graphically, and solved linear and quadratic pairs. Good luck with your IGCSE revision.